Okay, it's even worse than I thought because you sort of saw the email that, or the announcement that this was supposed to be attempt number 4 at taping this particular video. We are now on number 5 because I screwed up number 4 as soon as I got to it today or this afternoon. So hold on tight. I have no idea if I'm going to be able to land this plane or not. I'm almost to the point where I'm just going to say, well, you can probably guess what phrases I will say. But I'm gonna throw my arms up and just claim a mental health day because I can't keep recording this same video over and over again. And now is where I think to myself, well, now might be a good time to learn how to edit. I've made it through all the way up until this point without screwing things up too badly. This damn video has taken way too many times. So I'll be completely honest. The only thing I'm really afraid of with this, other than it, like the ceiling collapsing, because that's the only thing that's left, is that I have said certain things so many times, I now forget if it's in an email or I've will have told you 20 times by accident now. So fingers crossed, let's see how we do. And I may just start drinking. So I don't think it's gonna hurt at this point, but let's get through this damn Anova. Okay, so the advice I think I need to give you, I included some of this in the last video or in the announcement that went out. Really, 2 things I want to say to the class. First off, be aware that we are, as a homework is coming in, and again, it's 100% my fault. Sammy and I have had trouble getting the email to me, and because I'm on sort of a different kind of server with regular person email systems, the homework was having a rough time getting through, and it got backtracked. So one of the things that I found in the homeworks that just got graded, 3 and 4 were graded. The grades was graded a couple of days ago. I actually just posted them this morning. But the idea is that there were a couple of people who were, I think someone was using Excel to do the columns. You can't do that. Someone forgot to include the work. One of you sent me a very nice note saying, work is on another page. Sorry, it was so messy. I wanted to rewrite it. And then you forgot to include it. So these are things that I should have taken care of a while ago. I just discovered them. But even with these little bobbles, everyone's been doing just fine. So don't use Excel, use the calculator. Make sure to attach the homework. And thank you for the nice note. But remember to send the attachment or to include the attachment in with the homework. We've all done that. So I'm not judging any of you. And certainly none of that is your fault. So you haven't been penalized for that, but going forward, it becomes important, especially for both the exams and as the homeworks are getting bigger and more involved. I need to see the work because if something goes wrong, I have to be able to figure out where it is to give you a heads up if you are doing something just incorrectly. So I need that work. Going forward, if it's not there, it's going to be marked as a 0. So there's your warning. I've said it like 5 times today, but you haven't gotten any of them because these videos keep having problems. The other thing on this one in particular, so the Anova was last Wednesday and yesterday's, so I'm taking this on Tuesday, obviously, last Wednesday and Monday's classroom. And it's important that you watch that video before you jump into this one because I sort of laid out the basic way it's being done, and I'm sort of doing some things that were, I sort of said these other kinds of situations can happen. So we have more groups than normal in this one, and we have unequal samples. There's a number of different things that are going on with this one. And if you are jumping into it just on lab day, which has kind of been okay before to some degree, today it's going to be difficult, and I don't think you're going to be able to follow along as easily as it has been. So please make sure you watch the classroom video on the Anova first, and then come back and do this, because the hour-long one was, I think, almost completely me going through and showing you the Anova, and then the post-hoc test, the Tukey. And there's some explanation for why those things are being done the way that they are, and some choices that are made that you do kind of need to understand about this before today. So you have to watch that one first. This one is sort of the walkthrough for lab, and then the homework will be attached with this. Because this is getting later, or this is getting too late because I've lost all my ability to sort of record videos, the homework isn't going to be due till Monday. So I'll put that on the homework when I link it up later today. Okay, so let's jump into the Anova. I will tell you, it doesn't get better every time I do this in terms of more interesting, more exciting insights into, wow, that's why math is useful. It just is like, oh, here's where I had to stop last time. So when you see me grimace a little bit, just understand I'm just trying to get through the day today. That's the only thing I've got going today. Okay, so we're gonna be doing the Anova. Then we're going to be doing one of the post hocs. And again, I explained on the other video, we're only going to be learning to do the Tukey. There are many others out there. I used to teach classes, the Newman-Cools, which is another one that's pretty straightforward to do with the same data that we get with the typical write-ups that I have for these. But because this is online, I didn't want to jinx our chances, and I'll make some changes to make sure that the only one you need to do is the Tukey going forward. Okay. So here's the setup. First time through, I didn't read this, so I didn't know what it was, but I know now. I don't even have to look at it. Communication professor worried about students in his class and their sources of the news. So he asked them where they're getting their information and wants to see if one is more effective than another. So this would be appropriate kind of research for a communications course. So it's really about teaching a specific classroom and something that an instructor is doing. I also want you to sort of understand that not all research is sort of laboratory based. This is, classroom based, job based in some cases. So it's not just research driven for these things. This is a fairly practical thing an instructor might know or might want to know about his class. So we have 4 groups of individuals, or 4 sources that individuals say is where they get their news. Sort of the national or network television sort of formats, and I would include in there like the CNNs of the group. They may get information from their hometown newspaper. And again, certainly you understand if you're from a city like the Boston Herald, slightly different than the Amherst-Lynchburg Progress, a little bit. So it certainly, Amherst doesn't cover the national news as well as the Boston paper does. The internet, which is a sinking cesspool of all sorts of stuff, and of course a program like the BBC or something like that, where it's sort of focused on world news and places outside America, hopefully having a more objective view of things than you might get here. Gave a test and wanted to see if these news sources were better or worse, and he would be encouraging students for, I would assume, assignments to watch certain sources and see what happens from them. So we want to know, are there differences between these groups? Now, again, spelled out in the video, we're just going to blow by it right now. Normally, if we find a significant overall F is the symbol for the analysis of variance, what you would find is that we do means testing if there was a significant finding, and we would determine with that means test, which for us is going to be the Tukey, which of these comparisons, which of these groups are different from each other, and all possible comparisons that we could make. We're stopping this particular ANOVA at the ANOVA, and when we do the Tukey, it's going to be a completely different problem, and I want you to get used to that going forward. I explained again the rationale for that in the classroom one, where if you make a mistake in the very beginning and it's linked all the way through, one mistake on step 1 of the ANOVA can carry through to the end state of the means testing. So this is just to make sure that if an error has happened, that there's a break and it won't continue on and infect essentially another question. So that's the reason we're doing this separately. But because we're doing it this way, there are some little idiosyncratic things that we're going to have to do. And again, I walked through it once there. Some of this we'll be doing again today. Others I'll just be rushing through it and say, remember when this happened. Okay. So here's our data. And again, the 2 big differences of this data set versus the ones we did in the other classroom video is that this one has 4 groups. Remember, t-test has a 2 group, or 1 against the national norm. With the analysis of variance, we have more than 2 groups. So 3 groups and up is going to be the analysis of variance if we're looking for a parametric statistic, which of course means we have interval or ratio data. So in this particular case, we have 4 groups. The one before only had 3. And this causes us to do something slightly different when we get to the formulas. This goes back to that discussion I had about x of n. And the formula is written in a certain way that accounts for different data sets. And some will have more groups, some will have less. But the formula itself is written with that n in it. And 4 groups means we're going to be doing 1 step extra as we go through this. The other thing that this one has, just to show that it can be done, is that we have unequal sample size. And how do you handle when you have unequal sample size? It is something you must adjust for in a couple ways, both with the means and then with the sum of squares between groups. There are some adjustments that need to be made if the group sizes themselves are not equivalent to each other. So those are things that were not in the original. They're going to be here. So this will sort of answer any sort of combination I might come up with. What happens if there's extra groups? What happens if there's unequal sample sizes? And this one sort of we could not go forward and do a Tukey on because the Tukey test requires that we have equal sample sizes. So we would have to stop artificially at the point that we're going to today. Okay, step one. And notice that step one is chock full of a whole bunch of simple calculations. This is still the place where if mistakes are made, this is where they're being made. So I want you to do these again every time that one shows up. So make sure you have the data set out, make sure you got your calculator, make sure you got your formula page. I'll have the critical value tables for you today, but there are two different ones, the F test for the analysis of variance and the QK table, which is for the Tukey test. So they look kind of alike. They are two completely separate tables. So please make sure that you've got both of those when you're doing the homework, and certainly have those printed out when you're getting ready to do the exam. Okay, so step one is kind of the everything we've been doing all semester, do all of it. Okay, so I'm not separating these into like step 1, 2, 3, 4, 5. This is just do everything we've been doing. So notice what is required here. First off, we're going to be creating a squared column for each of the groups. So for x1, squared column for x2, squared column for x3, squared column for x4. And we need to sum up both the unsquared and the squared columns. So square everything to fill out those columns, then add everything up and get all 8 of these columns down at the bottom. After you do that, so that's calculate the sums of the columns, squares, and sums of the squared columns. You're going to calculate group means. So we now have 4 means that we're going to calculate. You need to calculate the total number of participants, count up the number of people here in the total experiment. And then for each of the 4 groups, how many participants fall into each one of those 4 separate groups. So all of that is step 1 now. All right. So as always, pause the video, get all that figured out, come back and check your answers. All right, let's see how this goes for us. So here are the answers. And again, I apologize. I'm sure the video of me is in the way here, but you can see their totals down here as well. And I'll just run through them quickly. Some of the x1 was 212. Some of the x2, 6436. Some of the x1 squared was 6,436. X2 was 138. Some of the x2 squares was 3,076. Some of the x3 was 22. And these are all listed over here. Some of the x3 squares is 100. Some of the x4 is 152. And some of the x4 squares is 5,090. The means. Group 1, 26.50, group 2, 19.71, group 3, 2.75, and group 4, 25.33. There are a total of 29 participants between the 4 groups, and it's on the next slide, but it's 8 in group 1, 7 in group 2, 8 in group 3, and 6 in group 4. So all of that is step 1, and you're going to use every damn one of these numbers along the way. Surprise if you didn't watch the video, this is our new reality. This one is the one that's got the most stuff in it. And we have several formulas to solve the Anova rather than just one. And then we got some simple calculations at the end. So this is why that video just walking through took over an hour. Again, the Tukey added some time to it, of course, as well. So make sure you've got all these values. If not, go back, double check where the mistakes are, correct it, add it. If any of these are wrong and you then go to the next step, it's going to be wrong at that point as well. So this is where our mistakes are still mostly being made. This is a stage I want you to focus on being a little bit more careful. Okay, so make sure you've got everything there and then go on to the next step. Okay, the next sort of 3 steps of the, well, actually all the rest of them, but we have sort of 3 formal steps and then we'll do some simple calculations off of a table. These are all brand new things. And again, these will all be listed on the formula page, but these terms, if you don't know where they are, go watch the video. That's my advice for everything this time is do that. So step 2 is we're going to have to calculate the sum of the x tote. So sum of the x tote is simply the addition of the raw score columns for each of the groups, not the squared columns, the raw columns. So, and again, there's actually, in some ways you can, if you calculate the squares column, you can use that to double check, but I've been doing this now for almost, well, 20 years. I've been teaching stats, and maybe 4 students have actually gone to the trouble of doing the double checking of this one. So I just was like, you know what, it's time to cut my losses and not force it on you. But this one we need for our formulas. So summing up the raw score columns, so 212 plus 138 plus 22 plus 152 gives us an x tote column or score of 524. And you'll notice, as I said in the video, it's nice to have all these things located in one general area so you can go back and pick anything out rather than having to flip through and finding things all over the place. So I do encourage, if there's any neatness gene in you, this is what you should be doing. If you don't have that neatness gene, this is really what you should be doing as well. Okay. So that one, and we'll just sort of plop it over along this side as well. And here's where we get to step 3. Now, this is a new source of variance. So both in the short video, I explained why we have a second group of variance now. That short video certainly you need for the kind of essay questions of exam 3. But the calculation is just the long video. So sum of squares between group variance is something we haven't seen before. And now it is something we have to calculate. So I did sort of a shorthand here. Remember as I said in the video, the sigma outside this parenthesis means that we're going to do this particular calculation for each and every one of our groups. So in the video where we had, the video before where we had 3 groups, I only had to do this 3 times. In this example, because I have 4 groups, I'm going to be doing it 4 times, and all of that falls within this set of parentheses right here. Now, I did the first one just to remind us, and then you'll have to do the other 3 that fit in here. But this is all within one set of parentheses. You add this up together, and then from this total, you subtract the second part here. So this is the x tote that we just calculated. Take that value squared, divide it by, again, capital N here. So not N of G, which is the number in a group. Capital N meaning total number of participants. So this would be the 29. And this is that 524 that we just calculated. Okay, so let's go down here. And for this one, sum of the xg, so the group, that quantity squared. So I take the sum of the regular column for x1, 212, square it, and then divide it by the total number of people within that group. So for this group, it had 8 participants. So that's the first thing that goes in the parenthesis. Okay, then you do this, which is this. Do this for the next 3 groups, add all of that together, and then subtract this quantity from it. Okay, so, and here are the, so this is group 1 has 8, 7, 6, and 8 for groups 1, 2, 3, and 4. Or is it, I'm sorry, go back, is it 8 and 6? I'm sorry, I screwed that up. It's 8, 7, 8, and 6. My apologies for that. God, I hope I have it right, or I'm going to have to do time number 6. Holy shit. Oh, I do have it right. Okay. I swear to God, this is the kind of stuff that's been happening. So this is what you should have. I should have paused there. Normally that might have been enough for me to say, I'll just start over. No, sorry. If you didn't work it out, here it is. No, not going back. Just not. I'm sort of I'm close to being on strike as I can be for today, and it's not going to get better. So I'm just plowing ahead, pretending that I did it right. Sorry. Okay, so there you go. This turns into this for each of the groups. Sum of the original column, that value squared divided by the number of people in that. So 212 squared divided by 8 plus 138 squared for group 2 divided by 7. 22 squared divided by 8 plus 152 squared divided by 6. So again, it's correct up here. It's just back-asswards down here. And then subtracting from that our 524, the sum of the x tote, quantity squared divided by total number of participants, 29. Now, I did recommend in the video, and I will say for this one, it's really actually very useful. I prefer at this point having another step of showing the work. So technically, when we've been doing the analysis up to this point, it was like write the formula down, show this step, and then you can kind of jump to the answer, because the next step really wasn't that complex. There wasn't a lot of stuff in there. And I think that's been fine up till now. Now we have a lot more going on. And I think for the Anova, this next step of showing your work is actually important. Because remember, the reason that you're showing your work is if there's a problem, both you and I can figure out where that problem is and try to address it before we get to an exam or something like that. So this is sort of solving for each of these components. So 212 squared divided by 8 is 5,618 plus this. So I'm just sort of doing another step of solving for these small equations, putting them all together, and then getting the final answer. So please include this step in terms of showing your work. It's been fine up to this point. We sort of know what we have to show and not. This one, I'm saying this extra step of showing this is necessary for doing it. Okay, so our sum of squares between is 2,781.6. So that's the end of step 3. Again, sorry that I gave you time to work on that, but please work through the math this yourself and make sure that everything is correct. I'll remember to pause now for the next one, step 4. We'll have the same sort of flavor to it. Okay, so boot that over here with the rest of our values. And now we're going to do the sum of squares within, which we've kind of been doing unofficially all the way through. Now, remember these G's are here. And again, sometimes the subscript shows up different ways if it's on the top or bottom. So the G is a little bit bigger than it should be. G just is there to indicate that this is group. Okay, so we're going to do this for group 1, for group 2 separately, for group 3 separately, for group 4 separately. Okay, if I took the G's out, what is this formula? Sum of the x squares minus sum of x squared over n. Okay, sum of squares. So what you're doing with this particular step, notice the summation sign on the outside of the parenthesis. We're going to do this function for each group. So we're calculating the sum of squares for group 1, adding the sum of squares for group 2, adding the sum of squares for group 3. That's what the summation symbol is. And for group 4, add them all up, and that is going to give us our sum of squares within. So I did the first one for you. So sum of the x squares for group 1, 6,436 minus sum of x, 212 squared over number within that group, which is 8. Then do the same thing for group 2, for group 3, for group 4. Okay, then, so that's the dot, dot, dots thing down here. Then, solve this parenthesis, just as we have that extra line of solving, put it here, group 2, group 3, group 4, and then add them all together, and it will give us our sum of squares within. Okay, go ahead and do all that, and I will see you back in a moment to check your answer. All right, so here's what we end up with for this. Now, again, make sure that you have these things correct. And our subtotal should have been 818 plus 335.43 plus 39.5 plus 1,239.33. Add all of those together, and you get a total for our sum of squares within of 2,452.26. Okay, again, do the math, make sure it's there. Now, notice that once again, I'm giving you the formula. I think I'll probably even put the mean on there, although I think you know it by now. But you can sort of see, looking at this, it looks a lot more confusing, even though this is just still sum of squares. It's the fact that we have these G's now to indicate we're doing it multiple times. It's looking different. And so you need to know how to do this, recognize what is being asked for at each of those steps, and it becomes a lot easier for you to do. Okay, so plop that up, and we're going to go into our F table. Okay, so here's the F table that we had. Remember that one of these tables will be provided whenever there is an analysis of variance. And we're going to do some of the simple math on the table. We still have more calculations to do, and we're just going to do them up here. So once we get to the table, you don't need to show the work. I know exactly where it's coming from. It's not a big calculation. It seems a waste to act, it's like 4 plus 7. It's not worth doing it. So once we get to the table, you have to figure everything out that's there, but then just do it in the tables perfectly fine. Again, talked about these. This is our between factor on the top row. This is our within factor on the bottom row. So we take the sum of squares between and within that we've calculated, 2,781.6 for our between factor, 2,452.26 for our within factor. Next thing, although it's calculated for you, is our degrees of freedom. These are down here. The n minus 1 is k, in this case is k minus 1. So again, I'm not really expecting this to be a difficult component, so I'm not going to spend a lot of time on this. But there is a mistake that people make here, and I pointed out before, but let me point it out again. So degrees of freedom between is listed. And again, these will be listed on the exam day. These will be listed within the formula, so you don't have to remember these. I will give them to you. Degrees of freedom between is k minus 1. K stands for number of groups, and you're going to need to remember that for, although I tend to put it down just like this, for the Anova, but also for the post hoc test. And actually one of the non-parametrics will use the same classification or the same symbol for groups. Okay, so k minus 1, we have 4 groups. 4 minus 1 equals 3. Assumed you didn't even need the calculator for that one because you've been doing good this semester. Degrees of freedom within is n tot, the total number of participants, minus k. Total number of participants was 29. We have 4 groups, so 29 minus 4 equals 25. Now, get my cursor back. This one down here, degrees of freedom within, although it's n tot minus k, this is a place people make mistakes. Okay, why? Well, we've just calculated this and we did k minus 1. And the idea is that this 3 is still sort of floating around inside your head. If you look at the table, you may have written 3 down there. What some people do is when they get to here, they go n tot minus 3. Okay. 3 is k minus 1. K is still 4. And it's a mistake that just happens. I can't really explain it other than just you're rushing or it's carelessness or whatever, but it's a mistake that people make. So remember, k is equal to 4. Okay, and subtract 4 from it, not 3 from it in this case. Okay, so 25 degrees of freedom within. Let me just jump ahead for a second. Oops, okay, yep. Pretend that didn't happen. Okay, the next steps here, of course, we're going to be working then in the table itself. And again, for this next part, for the mean squares and the actual F itself, you don't need to show the work for it. This is just a not numerator and denominator. I mean, it's a symbol multiplication. You have to put the answers down here, but we're going to let you skip the work on this one. That, you know, you had to add that extra line in for solving the degrees of freedom within and between. I'm going to let you skip off at this point of showing your work. Okay, so add the stuff earlier on, the extra step of solving here, I'm going to let you skip it. Okay, so mean squares is sum of squares divided by the appropriate degrees of freedom. So to get the mean of squared between, 81.60 divided by 3 will give us this. Sum of squares within, 2452.26 divided by 25 will give us the mean squares within. All right. Once we have both the mean squares, we can go to our F. F is mean squares between divided by mean squares within. So the top divided by the bottom to give us F. All right. We'll leave P absent for a moment. We need to go to the critical values table to figure this one out. But you can solve for the mean squares and the F. Okay, so mean squares, sum of squares divided by its degrees of freedom to get to the F, mean squares between divided by mean squares within. Okay, so do all that, come back and check your answers. All right, here we go. Okay, so for mean squares between, you should have gotten 927.2, mean squares within 98.09, and then 927.2 divided by 98.06 should give you 9.45. Now that is our final calculated value for the analysis of variance. Okay, ta-da, yay, all that work and one thing spit out. All right, so now we have to determine if this is significant or not. We're following the same rules we did with the t-test. Okay, so we have a calculated value. We're going to go look up something in our critical value table, this one just for the F, the analysis of variance. And if our calculated value is higher than or greater than the number in the values table, it is significant. If it is lower than, it is not significant. Okay, so what do we need to go into the F table? Well, you need your degrees of freedom. So our degrees of freedom are 3 and 25. So on the next page is the critical values table. And we look up the intersection of degrees of freedom 3 and 25. So take a moment. I'm not really going to pause. I'm just going to keep jabbering. Look for the critical value for 3 and 25 degrees of freedom. All right, so we have 3 and 25. All right, 3, and then down to 25, and that gives us a value of 2.99. Now, well, I'll say something for the Tukey test, because the Tukey test is almost, I'm sorry, the QK tables is the thing I'm referring to in the Tukey. Essentially with the QK table, it's like every value is shifted 1 over, okay? And I'll explain why that happens when we get there, but make sure you're using the right table. That becomes very important. Now we have multiple tables to be looking at. Critical value for the analysis of variance, use the F table. Make sure you're using the F table, okay? Based on degrees of freedom in the F table. Okay, so our critical value for 3 and 25 degrees of freedom, 3 and 25 was 2.99. Okay, so our critical value is written down there. And then our final format, F, which is the symbol for analysis of variance, with 3 and 25 degrees of freedom, and this is the order it goes between then within, is equal to our calculated value of 9.45, comma, P is less than 0.05. And where did that come from? Our obtained value is greater than the critical value. That is statistically significant. Statistically significant is P is less than 0.05. So just the same as we did with the t-test. If this was not significant, and so our F value, let's say, was 1.7, then P would be greater than 0.05. Okay, now at this point all the way through, I've been saying, I also want you to interpret it. Well, we can't really interpret it too much at this moment. What would happen, again, this is a reminder for things I've mentioned before, but this is a quick version of it. If you have an overall significant finding with an analysis of variance, the next step is to then do means testing. We're using the Tukey, but there are other ones that are out there. You do a means test, and you're going to see of all the possible comparisons that could have happened, okay? Because we're going to be doing pairwise comparisons. Which of these groups are different from each other? Of all the possible combination of pairs that are out there, which ones themselves are statistically different from each other, and which ones aren't? Okay, so again, talking about the separateness of these comparisons of one group in here and against another. So if we have a 4-group analysis here, the mean comparisons you would have to make would be 1 versus 2, 1 versus 3, 1 versus 4, 2 versus 3, 2 versus 4, and 3 versus 4. So for 4 groups, you would have 6 mean comparisons. Just get the mean values that we calculated at the very beginning, subtract or get a different score of the two, whether it's group 1 and 2 or 1 and 4 or 2 and 4, get the difference between them. And then on the Tukey test, we would be looking to see are those significant differences. All right, remember that in this, and again, in terms of interpretation, you really need those mean comparisons and know which ones are different from each other to really interpret this. Right now, what this tells us at this point, and this is as far as we're able to go because I'm changing data sets for the Tukey. At this point, all we could say is that there is an overall significant finding. Not all groups are equal to each other, okay? But we can't go further than that without doing the means test. And again, I've explained before why we're sort of stopping at this point and then doing means test independently. So for interpretation of the Anova, you can only say there's an overall effect saying not all the groups are alike, or you fail to reject the idea that not all of the groups are alike or different. And that's as much as you can say. Okay, means testing is where you find out what groups are done. So if we carried on with this, we would now then do a means test using the data that we've calculated. For us though, we're changing our data sets because if a mistake was made, we don't want to link the 2 questions together. So make a note here, that's why little chicken things there, close as I can get to a Tukey. The idea here is that this is a separate data set. I'm going to put up a different F table. And when I do this on the Anova, or I'm sorry, on the means test or the post hoc test, I'm going to have to give you all the necessary data. So I'll have to give you group means. I will have to give you some information, and others you're going to have to learn to calculate. So we'll walk through those steps again, even though I did in the last one. In case it's confusing, I'll walk you through the more confusing portion of this. Okay, so onward for the Tukey. Truthfully, if this was a real analysis, we would use the data we just calculated. We're doing this separately. Okay, so You can read this. This is a group, an auto company. I don't know why I keep going to car examples for these things. There's been a number of them showing up. A car manufacturer has a GPS system, and they make changes to their own version. They have 3 different models, and they want to see, is there a preference of customers or users for any one of these methods? Is there one that is seen as easier to use, and therefore the one that would help sell a vehicle? So that's where this data is calculated. It's a different data set than we did with the Anova. Now, I'm sorry, let me go back for just a second just to point out one thing. Notice that in this data set, there's only 3 groups. So it definitely is not the last analysis. The last one had 4 groups. This one only has 3. The other thing is a reminder about the Tukey. The Tukey assumes that all group sizes are equal. So there's an equal number of participants in each of these 3 groups. Okay? Again, in our last Anova, that was not the case. Okay? So we couldn't do a Tukey on that data anyways. Okay? So here's our F table. The means are covered up even for me actually at this moment. So let me at least read these for you. So here's our F table. Sum of squares, degrees of freedom, mean squares, our F. So this one is also significant, which, and again, as explained before, in the absence of an overall significant finding or an a priori reason, we wouldn't do the test. But if we have a significant finding, we then go ahead and do the post hoc. So this one is significant. We would then go ahead and do the post hoc means testing. Okay, so in this case, we have 3 groups. So if this is a question on homework or an exam, you would be given this F table. Okay, you would be given these means. Okay, these are from a different data set. You don't have to calculate them. I'm just giving them to you because you did it in the Anova. So you're getting credit essentially for that. Now, again, because this, the video box of me covers up the means, the mean of group 1 is 6. So please jot these down somewhere. The mean of group 1 is 66.67. The mean of group 2 is 34.44. And the mean of group 3 is 51.22. So those are their, and would be given to you. Okay, now our Tukey formula, and here's the Tukey test. And this one, again, as mentioned before, we're calculating something a little bit differently. And what we're doing now is in the Anova, we actually calculated what was our obtained value, the mathematical version that we compared to something in the critical table, okay, to make that determination if something was significant. What we're doing with the Tukey is we are actually calculating the critical value. All right, so we're going to be calculating something, and when we do the mean comparison, we're comparing those differences to this as our critical value. So we're still going to go to a table, but that critical value is not, or what looks like a critical value table is not the critical value. It is part of our formula now. Okay, we're going to be calculating our critical value, and that's what the Tukey is. Now we have some of this information. We have, and we don't have some of this information. So the HSV formula QK, which we're going to get from a table, is equal to the square root of mean squared within divided by n minus g. What things do we know? What things don't we know? Well, we certainly know the mean squared within. That's up here. So our within factor is the bottom line. Here's our mean square. So this right here is going to be 216.25, mean squared within. All right. We'll get to the sample size. You have to figure this out. This is that little thing, and it doesn't show up in a formula page. You're going to have to remember how to do this. That's sort of the new stuff we're adding, is these now, the analyses themselves have sometimes little exceptions and little rules that don't show up in a formula page. You just have to remember them. And it's unfortunate, but that's the new thing we're adding in this time. Okay, so we'll get to NG in just a second. And we have this QK. Now, the QK we actually are able to use, and we're going to go to a table. Let me explain it. I'll have you look up the thing on the next slide, and it's the table to get there. Now, what we need for the QK is the number of groups. Okay, now we go back to the original question here. We had 3 groups, 3 different GPS versions. So we have 3 groups, and we have 24 degrees of freedom within. Okay, so remember it's within because we're looking within here. So we're looking for 3 and 24. Now notice the table here has 2 and 24. That's because this was number of groups minus 1. Okay, we want the number of groups when we look at the table. And here's the QK table. Now this is cut off because It's one of those weird tables that crosses pages, but it's really just the heading that goes over. So this is the number of levels. This is the number of groups we have. So we have 3 groups, and we have 24 degrees of freedom. And again, here's where you're seeing, this is why I put all those different terms up there. This says degrees of freedom in the error term. The error term is our within version. So that was the 24, and we have 3 groups. Okay, degrees of freedom were 2 and 24, but we're looking at how many groups, K, which is 3, and 24 degrees of freedom. So we go across here to 3, and then down to 24 to get our QK value. So again, this one, you know how to read tables. Get my cursor back. It is. So 3 and 24 gives us a value of 3.53. That's the value that we're going to use in the calculation of the Tukey. Remember, in the other video, I went through great detail what happens if your degrees of freedom don't show up on the table and how you handle that. This one, it does show up on the table, so refer back to the other video to find out that answer if you didn't watch it. Another reason that I've snarkily thrown in to make sure you watch these videos, because I got to make them, so you got to watch them. All right, so our value of 3.53 is our QK value, and we're going to put that back into the formula right here. Now we have our N of G. So how do we get this one? Again, a more complete work through was done in the original video. I have both, I'll go through it orally, and then I've got a little written sort of cliff note version of where this comes from. So if it doesn't make sense when you're hearing it, the next slide will have it sort of jotted down where this comes from. Okay, so 2 things we have to remember. First thing is overall, when we did degrees of freedom, the overall finding for, by the way, the one of you, thank you, who watched the degrees of freedom video. I had to do it, but I really, because it's optional, I didn't think anyone would watch it. So one of you did, so thank you. Makes me just all warm in the heart. Really, if we think about degrees of freedom, it's always n-1. Okay, so just stick that right here for a moment. Stick over here the idea that all groups for a Tukey are of equal size. Okay, those 2 facts are things we need to remember in order to solve this. So we have degrees of freedom here, 2 and 24. Okay, so if we add 2 and 24, it gives us 26. But remember, overall degrees of freedom is n-1. So we have 26 of them listed here, plus 1, that degree of freedom, that's that n-1. So we now have 27 total degrees of freedom. The 26 listed here plus 1. We have an equal sample size. We have 3 groups. We're going to take 27 divided by 3, which will give us 9 participants per group. Okay, that's the backwards math to get to what is the sample size. All right, all the data is here. You just have to work back at it. But you have all the pieces, and it really isn't that difficult when you're doing it. Let me move the screen here. So here it is written out. We know that overall degrees of freedom is n-1. So we have the 2 here plus 24 degrees of freedom between and within, plus 1 for that -1 here. So that gives us 27 total participants. You also could have figured it out, or when we did the original Anova, we got there by just adding up the number of people. But this one, it's not there. So we'll look at degrees of freedom between and within, add 1. That gives us total number of participants. Okay? In this case, 27. We know that there are 3 groups because that's what was listed. That's how many means we have. So we know that there are 3 groups. So 27 divided by 3, because there have to be equal sample sizes in these. So we can just divide that by 3. And that's going to give us 9 people per group. All right. So now we're going to take the 9 and put that in down here at N of G, the number within each of the groups. All right. Now we're going to solve. So 216.25 divided by 9, take the square root, then multiply that by 3.53. And that's going to give us our, we call it the HSD value, but it's our critical value. Okay. The next thing you have to do in the next portion of this is you have to get the mean comparisons done. So you go back to those means, and we have 3 groups here. So all the possible comparisons are 1 versus 2, 1 versus 3, and 2 versus 3. Okay, so if we have 1 versus 2, that's the same thing as it was 2 versus 1. Okay, so number of independent group comparisons, If we only have 3 groups, there are 3 comparisons to make: 1 versus 2, 1 versus 3, and 2 versus 3. All right. When we had 4 groups, there were 6 comparisons, as I sort of showed you with the Anova. But we have to make these 3 comparisons. So solve the Tukey, then you solve the mean comparisons. 1 versus 2, 1 versus 3, 2 versus 3. Find out the difference score. So 66.67, which was group 1, in comparison with group 2, 34.44. So subtract 34.44 from 66.77. That is the mean difference between groups 1 and 2. Then do the same for 1 and 3 and 2 and 3. Okay? So solve that and then come back. So solve the Tukey, solve all the mean comparisons, and then come back for the last step. All right, here we go with the last step. So, well, actually there's a little, I put the 9 in there. That's apparently what this slide was for. So the solution for this, if you didn't do it, the solution to the HSD was 17.30. And then I did the mean-wise comparisons, 1 versus 2. And this one is 2 versus 3 and 1 versus 3. In here, you can compare the absolute value, so it doesn't really matter which direction you go. But since we're not using the negative values, I just take the largest one and subtract the smaller of the 2. So sometimes it's 1 versus 2, but 2 versus 3. Okay, I just put the largest one first so I don't get negative values. The difference for 1 versus 2 was a value of 32.23. For 2 versus 3 was 16.78. And for 1 versus 3 was 15.45. Now, our critical value, the thing we've calculated, is 17.30. Any mean comparison that is greater than 17.30 is statistically significant, and that comparison itself is significant. So there's only one of these 3 comparisons that was significant, and that's the difference between our group 1 and our group 2. 2 and 3 weren't different from each other, and 1 and 3 were not different from each other. I mean, they were actually different from each other, but not statistically significant from each other. So what that means is, even though we have an overall F that says these groups are not alike, okay, some groups are different from each other, and it's a bigger finding. I mean, our last F was 9 point something, this one is 10.8. So it's, I hate this term, but it's more significant. This would be significant at 0.0, let's say 3 rather than 0.04. Okay. The idea would be that that entire F is mostly carried by one of the potential comparisons, and that's between groups 1 and 2. So what you would say is that the only difference between the pilot study or the pilot GPSs were 1 versus 2. And when you look at the mean scores, 2 was certainly the weakest. This is the one that had the least number of people supporting it. So you can kind of figure out that 2 is the worst of the 3, not significantly so. So if your choices were 1 versus 3, well, it doesn't really matter which one you choose. If your choices were between 2 and 3, either one is fine. Even though this mean is higher, it's not statistically significant. If those were your only 2 choices, either one would be just fine. I mean, we would tend to go with the one that has the higher mean, but there's really no statistical reason for doing that. If our comparison is 1 and 2, certainly 1 is the one we want to go with. It has a higher mean score, and we know that it is statistically significant, or in this case, significantly better. It has the higher mean. If you have all 3 of them together, I would choose number 1. I would go with the GPS system for number 1. Yeah, it's not different than number 3, but it is statistically significant than number 2. So it's certainly higher up on the list. And that's at least one comparison that sort of pushes for 1 being better. And if that's the only one that's significant, in choosing between 1 and 3, I would just go with number 1. There's some evidence that it is the best of the 3 there, but the only real statistical difference is between groups 1 and 2. So when you're interpreting, it kind of depends whether you're comparing or looking at just 2 groups together, or you're looking at all the data together. And with a significant finding, putting group 1 at the top, even though all comparisons weren't significant, that might be enough to say go with the first of these GPS systems, because there does seem to be an advantage for it. Holy crap, that is the end of the Anova and the Tukey. I have made it through. I am getting rid of you right now. I am stopping taping. I am not going to jinx this. Hi, goodbye. Have a great life. Hope everything goes well. Hasta la vista, baby. Bye-bye.